With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, the question is, if the pressure of N2 and H2 mixture in a closed vessel is 100 atmosphere and 20% of the mixture reacts, then the pressure at the same temperature would be. So in this question, the pressure of N2 and H2 mixture in a closed vessel is 100 atmosphere and 20% of the mixture reacts. Then we have to find out the pressure at the same temperature, right? So let's start. So for the reaction and the reaction is N2 plus 3H2 on reaction will give 2NH3, right? Now we have to find out the number of moles. So at T is equals to 0, number of moles for N2 is 1, number of moles for H2 is 3 and number of moles for NH3 is 0. Now at T is equals to equilibrium, when it will be at equilibrium, then number of moles for N2 will be 1 minus alpha, number of moles for H2 will be 3 minus 3 alpha and number of moles for NH3 will be 2 alpha, right? Now moving forward. So basically by stoichiometry of the reaction, initially total number of moles, let's consider this as N1 will be 1 plus 3, that will give 4, right? Now at equilibrium degree of dissociation that is alpha will be 0.2, as we have given that the 20% of the mixture reacts, right? So now moles of N2 at equilibrium will be 1 minus alpha, that is 1 minus 0.2, and it will give the value 0.8. Similarly, moles of H2 at equilibrium will be 3 minus 3 alpha, so it can be written as 3 minus 3 into 0.2 and it will give the value 2.4. Similarly, moles of NH3 at equilibrium will be 2 alpha and it will give 2 into 0.2, that will give the value 0.4, right? So therefore total number of moles at equilibrium, that is N2 will be 0.8 plus 2.4 plus 0.4, and after solving this we will get 3.6, right? Now using ideal gas equation, that is PV is equals to nRT, where P is the pressure exerted by the gas, V is the volume occupied by the gas, N is the number of moles of the gas, R is the universal gas constant, and T is the absolute temperature of the gas, right? Now as this reaction is carried out in a closed vessel in a closed vessel, so the volume of the system remains constant, right? And it is given that temperature will remain same, so therefore both temperature and volume remains constant, right? Now moving forward, so basically initially pressure is 100 atmosphere that we have given, and number of moles are 4 moles that we have found out. Now let's take this initial pressure as P1. So the equation will be P1V is equals to N1 RT. Right? Now coming to the final condition. So at final condition we have to find out the pressure, that is P2, and number of moles we have are 3.6 moles. Right? So now the equation will be P2V is equals to N2 RT. This is N2 and this is N1, right? And this is equation 1 and this is equation 2. Now what we'll do, dividing equation 1 by equation 2, right? And what we'll get, P1 by P2 is equals to the N1 by N2, right? Now let's put the values. So value of P1 is 100 and we have to find out the P2, right? Value of N1 is 4 and value of N2 is 3.6. So from here P2 will be 100 into 3.6 divided by 4, and after solving this we will get 90 atmosphere. So therefore if the pressure of N2 and H2 mixture in a closed vessel is 100 atmosphere and 20% of the mixture reacts, then the pressure at the same temperature would be 90 atmosphere. So option 3 is the correct answer. So this is the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.